Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear students, today we will do new topic, which is area of parallelograms and trends. First of all, we will define some definitions. First definition is what is meant by planar region. The part of the plan enclosed by a simple closed figure, enclosed by a simple closed figure. Simple closed figure is called a planar region corresponding to figure. Is called a planar region corresponding to a figure. Corresponding to a figure. Corresponding to a figure. The magnitude or measure of this planar region or measure of this planar region is called the area. Is called its area. For example, this triangle or this quadrilateral, this is the closed figure. The magnitude of space enclosed by this figure, part of the plan enclosed by this figure, this is called planar region. And the magnitude of this planar region, is called area. It's called planar region. After this, we will define congruent figures. Two figures are said to be congruent if they have the same shape and same size. For example, these two figures ABC, DF, if they have the same shape and same size, these are called congruent figures. Other words, two figures A and B are congruent then using a tracing paper you can superpose one figure over the other such that it will cover the other completely. So, if two figures A and B are congruent, they must have equal area. In other words, congruent figures have equal area. However, the converse of this statement is not true, we must see that two figures having equal areas but need not be congruent. After this, we will explain area of a figure. The area of a figure is a number in some unit, associated with a part of the place, enclosed by the figure Following two properties. Number first, if A and B are two congruent figures, then area of A is equal to area of B. For example, these are two figures which are congruent. Area of A is equal to area of B. After this, if a planar region T, this is T, is made up of two non-overlapping planar regions P and Q. Number second, if a planar region formed by a figure T is made up of two non-overlapping planar regions formed by P and Q then area of T will be equal to area of P plus area of Q. We will explain figures on the same base and between the same parallels. Two figures are said to be on the same base and between the same parallels. if they have a common base side, if they have the common base side and the vertices or the vertex and the vertices or the vertex opposite to the common base, opposite to the common base of each figure lie on a line parallel to the base, parallel to the base out of the two parallels, one must be the line containing the common base. One must be the line containing the common base. For example, these are figures on the same base and within the same parallels. This is ABCD parallelogram, and this is another parallelogram, and F. Here two parallelograms ABCD and BCEF are on the same base BC, and between the same parallel lines AF and BC. The opposite vertices, that is A, E, D and F, are opposite to the common base, which is BC. These are the figures which are on the same base and between the same parallels.